Healthy day, learners! This is Teacher Mayan of the Visao AVP Mathematics team. Our team will guide you as you enhance your skills and sharpen your minds as you face the challenges of Mathematics 8. Brace ourselves as we start with our first lesson on Mathematics 8. Factoring polynomials with common monomial factor and difference of two squares. To start, grab your learning activity sheet, pen, notebook, and let's have fun!
Factoring polynomials with common monomial factor and difference of two squares. Factoring is a useful skill in real life. Common applications include recognizing patterns, dividing something into equal pieces, exchanging money, comparing prices, understanding time, and making calculations during travel. Let's start with Lesson 1, Factoring Polynomials with Common Monomial Factor. With the definitions of prime numbers, variables, numerical coefficients, and exponents in your learning activity sheets, let us also recall the following concepts. Let's take a look at these three given numbers. We have here 3, 6, 9. What is common to these three numbers? Okay, so they are all odd numbers. Aside from that, these three numbers are all divisible by 3. To show that 3 is a common factor of the three numbers, let us find the factors of each. So for 3, it has factors 1, 3. 6, the factors are 1, 2, 3, 6. For 9, it has factors 1, 3, 6, 9. So notice here that all of them has a factor of 3. Let us have another set of expressions with elements b, 2b, 3b, 4b, and 5b. What is common to the given expressions? So, they all have the variable b. Therefore, the common factor of the given expressions is b. What do we call a factor that is common to a set of numbers or expressions? We call them the greatest common factor, GCF, or common monomial factor, CMF. What is greatest common factor or GCF? Simply, it is the largest of the common factors of two or more numbers or expressions. Once the GCF is wrong, the other factor will also be wrong. So, be very careful. Prime factorization is a way of expressing a number or expression as a product of prime factors. A prime number is a number that has exactly two factors, 1 and the number itself. Prime factorization is one way of determining the greatest common factor of two or more numbers. Let's have examples. First, we have here, find the GCF of 4 and 8. So, to find the GCF of these two numbers, we are going to use the factor 3. Let us have the factors of 4. So, we have here 4. The factors of these are 2 and 2. Since 2 is a prime number, we are going to encircle these two factors. Now, let's have the factors of 8. So, we are going to split 8 into 2 and 4 since 2 times 4 is 8. And since 2 here is a prime factor already, we are going to encircle it. And then let's again factor 4. So the factors of 4, we have 2 and 2. So we encircle again. So we have here the prime factors of 8 to be 2 and 2 and 2. So we have here factors of 4, 2 times 2, factors of 8, 2 times 2 times 2. Now we are going to get the common factors. Now we determine the common factors of 4 and 8. So we have here 2 and 2. So we have two common factors. These two common factors, we are going to multiply them to get the greatest common factor of 4 and 8. So 2 times 2 is 4. Therefore, the GCF of 4 and 8 is 4. Let's have another example. Find the GCF of x squared, x cubed, x raised to 4, x raised to 5. So these are monomials. And we are going to do the same thing. We are going to find first the factors of each given expression. So since x raised to 2 is equal to x times x, x raised to 3 is x times x times x raised to 4 is x times x times x times x raised to 5 is x times x times x times x times x. Now we are going to get the common factor of the four expressions, which is we have here x and then another x. So to get the greatest common factor, we are going to multiply the common factor. So multiplying x and x, we have x squared, which is now the greatest common factor. Now let's have an example of expressions with a whole number and variables. So it says find the GCF of 4x squared and 8x. So the same thing, we are going to find the prime factors. Let's have first 4x squared. We are going to first find the factors of the whole number, which is 4. We know that the factors of this are 2 and 2. And for x squared, the factors are x and x. Now let's have 8x. So we know that the prime factors of 8 are 2 times 2 times 2. And then for x, that is x. Now we determine the common factors. So the common factors, we have 2, 2, and then x. Now we multiply these common factors. 2 times 2 is 4 times x is 4x. Therefore, the greatest common factor of 4x squared and 8x is 4x. So that is how to get the GCF or CMF of given expressions. Now, we are going to connect this to our lesson, which is factoring polynomials with common monomial factor. How do we factor polynomial under this lesson? So you have the following steps on your learning activity sheet. So you need to review those steps in factoring polynomials with GCF. Take note that factoring is the reverse process of multiplication. And in factoring a polynomial, we simply express the polynomial as a product of two or more factors. Like, for example, we have here 6. So it means that if we are going to factor 6, we are going to look for the two numbers that when we multiply, it will give us the number 6. So we have here 3 and 2. Another one, 4, we have 4x plus 8. So if we are going to factor this out, it means that we are going to look for the expressions that when we multiply, it will give us this expression 4x plus 8. And the factors would be for the quantity x plus 2. Let us have the following examples. Example 1. Factor the polynomial 4x plus 8. So the first step here is we are going to find for the GCF of 4x and 8 by prime factorization. So the factors of 4x, we have here 2 times 2 times x. The factors of 8, we have 2 times 2 times 2. Now, we determine the GCF by identifying the common factors, and then these common factors we multiply. So the common factors, we have here 2 and 2. Now we get the product. 2 times 2 is 4. So 4 is the GCF. To get the other factor, we are going to divide the polynomial by the GCF. So we have here 4x plus 8. We divide it by 4 and we will have x plus 2. So the factored form of 4x plus 8 is for the quantity x plus 2. Example 2. Factor the polynomial 5x squared y cubed minus 30x raised to 4y. So first step again, we are going to find the GCF of 5x squared y cubed and 30x raised to 4y. Again, to find the other factor, we are going to divide the polynomial by the GCF, which is 5x squared y. So we have here 5x squared y cubed divided by 5x squared y. So 5 divided by 5 is 1. X squared divided by x squared is 1. And then y cubed divided by y is y squared. So we have here y squared. Next, we have 30x raised to 4y divided by 5x squared y. So 30 divided by 5 is 6. X raised to 4 divided by x raised to 2 is x squared, because we are going to carry the base, which is 6, and we are going to subtract the exponent. So 4 minus 2 is 2. Now y divided by y is 1. So the other factor, we have y squared plus 6x squared. Now with the GCF and the other factor, we now have the factored form of 5x squared y cubed minus 30x raised to 4y to be 5x squared y, the quantity y squared minus 6x squared. What is a perfect square number? This is a number that is the result of a number multiplied by itself. Can we also have terms that are perfect squares? Of course we can have. For example, if we are going to multiply a by itself, which is a, it will give us a squared. Therefore, the term a squared is a perfect square term. So how do we determine if a given polynomial is a difference of two squares? So we are going to check the two terms of the polynomial. If the numerical coefficient is a perfect square number, and if all the exponents of the variables of the term are even numbers. And of course, since we are dealing with difference of two squares, the sign of operation must be a minus sign. We have here examples of differences of two squares. So we have x squared minus 36. X squared is a perfect square term, and so with 36. 4x squared minus 25. So 4 is a square number. X squared is a perfect square term also, and 25 is a perfect square number. How do we factor difference of two squares? Let's take a look at the pattern. So we have here a squared minus b squared. So this is the difference of two squares. The factors of this expression would be the quantity a plus b, the quantity a minus b, the quantity. Have you observed the pattern in getting the factor of difference of two squares? If yes, take note that we can only use this pattern if the following conditions are met. First, it must be a binomial. Second, both terms must be perfect squares. Third, there must be a minus sign in between the two terms. So let's take a look at these examples. For example 1, factor x squared minus 36. So to get the factors of this, we are going to first set up two parentheses with plus sign in one parenthesis and minus sign in another parenthesis. Next, we take the square root of the first term, which is x squared. So, the square root of x squared is x. So, we write it as the first term of the two binomial factors. Next, we are going to take the square root of the last term, which is 36. So, the square root of 36 is 6. So, we are going to write 6 as the second term of the two binomial factors. Therefore, the factors of x squared minus 36 is x minus 6, the quantity x plus 6. Another example, factor 4a raised to 4 minus 1. So, the same thing, we are going to set up two parentheses with the plus sign on the other one and a minus sign on the other one. Though we can interchange, we can have the first one to have the minus sign and the second one to have the plus sign. And then we are going to extract the square root of the first term. So the square root of the first term, 4a raised to 4 is 2a squared. So again, we write it as the first term of the two binomial factors. So we have your 2a squared, 2a squared. Next, we get the square root of 1. So the square root of 1 is 1. So we write 1 as the second term of the two binomial factors. So we have your 1. Therefore, these are the factors of the expression 4a raised to 4 minus 1. We have the quantity 2a squared plus 1, the quantity 2a squared minus 1, the quantity.
That's it for the discussion. For the activities, please read and understand each of the instructions before doing them. You use the answer sheets provided if you have. Good luck, learners! This is Mayan Kadawang with my team saying, mathematics gives us hope that every problem has a solution.